We're not going to focus on slope-intercept form, though, just yet. So that's getting a little bit ahead of ourselves. We're just focusing on what the slope is. Okay? So a slope is a rate of change here. In order to find the rate of change, well, what did we do for the rate of change earlier, right? What did Tyler do? He took the distance that Mr. Witt had traveled, and what math did he do? Distance over time. And over means what? Divide. And so what we're going to do is we're going to be dividing two quantities here. Okay? Okay? F of B minus F of A over B minus A. This will be the slope, or also the average, I'm going to abbreviate here, average rate of change. Oops, why did I put parentheses around there? Darn it. I want a parentheses around the slope. I'm going to fix that real quick here. Okay. So average rate of change, or the slope. Okay. And for lines, these two words are these two ideas are kind of synonymous with each other. They mean the same thing. So let me just forgive me here real quick. Just kind of erase that away because it looks kind of sloppy otherwise there. Okay, a little titanium white. Anyone watch Bob Ross?
Yeah.
Yeah, all right, there we go. So this is a titanium white. All right. Phthalo blue and titanium white. Anyway, so that's the slope formula. You might remember it in a different format. Maybe you might remember it as y2 minus y1 over
x2.
There you go, x2 minus x1, right? Okay. So in other words, in order to find the slope, what information do we need? Well, you can see we have an x coordinate, excuse me, an x coordinate and a y coordinate, and another x coordinate and a y coordinate, right? X sub 1, y sub 1, y sub 2, x sub 2. So it is the rate of change from the point x1 comma y1 to x2 comma y2. Well, I should put the words average in there. Okay? So two different formulas for the same thing. Remember that functions, when you evaluate a function, that's like a y value, right? The output of a function, so we take our b and our a, which are like our x values there. We plug them into our function, whatever it happens to be, okay? And the output is our y values. So f of something is like a y value. F of a is another y value. B and a are both like x's there. Okay? So that's the idea. So,
Okay, did you say that last part again? So the F
yes.
of B is a y value.
F of B.
F of A is a y value.
Yep.
And then the
B and the A are like the x values then. So, or if you want to think about it this way, independent, dependent, right? Inputs, outputs. It all is coming together.
It's all coming together.
That's right. Okay, so let's do some problems here, right? So, find the slope of the linear function that contains the 2 points. Okay? Do you have to? You don't have to, but if you're going to look back at your notes and maybe study or something like that, and you just see a bunch of numbers written and you don't know what it means, it might be helpful to write it. Okay, you can abbreviate if you want to somehow. You know, you can just write find the slope if you want to or something. But I mean, I would still suggest you write a little bit of something just so you have some context for what you're writing here. Okay. And again, I don't just have you guys write these notes to fill in time. You know, I mean, the point of these is for you to go back. If you're doing your homework and you're like, what am I supposed to do here? Let me go back to the notes and see what we did there. And then you can be like, oh, that's what I'm supposed to do. And use it that way, okay? These are not supposed to be, okay, frivolous, meaningless. You know, they're meant to help you, okay? And give us practice, too. Okay, so let me start here with number 1. we'll just do an example. Let's say we have the points 3, -1, and -5, 4. Like that. Okay? So, we want to find the slope between these 2 points. So I'm going to write down slope formula. Okay? So we're going to write y2 minus y1 over x2 minus x1. Okay? y2 minus y1 over x2 minus x1. Now, when I see students do this sometimes, I see them do some organization before they actually do their calculation. And this can be helpful. So what do we mean by organization? They label the coordinates here as being x's or y's. So 3, for example, is that an x coordinate or a y coordinate? It's an x, right? And since it's the first point, we'll call it x1. Okay? And then -1, how would I label that one? y1, right. Okay? And then -5, x2, right. It's an x coordinate, but it's the second x coordinate there. And what about the 4? y2. You guys got it good. Okay? So now, you see how this labeling helps us? All you have to do now is plug these numbers into our little formula here to get that slope. Okay? Which is the rate of change between these 2 points. Okay? How they're changing from here to here. Okay? So, put in for y2, the 4, minus the y1, which is -1. I'll put that one in parentheses because it's got the minus the negative there. Over x2, which is -5, minus 3. Okay. Hey, that looks just like the warm-up. It's almost like Mr. Widd wrote the warm-up to prepare us for what we're going to see later. You're welcome. Yes, yes. I try to help when I can. Believe it or not, my goal is not to make you more miserable than you need to be. My goal is to make you a little miserable, I guess, but not more than you need to. Okay? All right, so we're going to solve this. We just simplify here. So I have to do 4 minus -1, but instead of minus a negative, I can make it what? Plus +1, right there. When I subtract a negative, I can really make it add the opposite there. So we get 5, and then -5 minus 3. Well, again, I don't really like subtracting, so I'm going to make it plus -3 instead. -5 plus -3, that's -8. So what's my slope? 5 over -8, or if you like, you can make it -5 over 8. It's really your choice. Oops, I wrote that awful 8. There we go. So this one or this one, your choice, how you want to describe it there. They're the same thing. They're the same thing. Okay? Yes, Kate?
Why are we adding?
Why did I change it to addition? So remember that, well, so you've seen before that when you subtract, you can change it to add opposite. So when you want to subtract something, you can instead add the opposite or do like leave. Sometimes it's called leave, change, or same, change. Have you heard about that before? Never heard anything like that before? Okay. So, I mean, if not, you can just do the subtraction if that's what you're comfortable with. Okay? But it turns out that, for example, if you have something like 4 minus -1, that is the same thing as 4 plus a +1. Okay? They are doing the same thing. Okay? Just like anytime you do division, you can really make it multiplication by the reciprocal and stuff like that. Same kind of idea. Okay? So, yeah. But again, if you're comfortable with subtraction, do subtraction there. I was just trying to show people for the sake of helping them do the mental math. All right? Does this fraction simplify any further? Yeah, no. If you're unsure, you want to check, you can type -5 over 8 into your calculator. And then what do I press to see if the fraction simplifies? Math. Enter, enter, and it doesn't. It just gives me that -5/8 again. So it doesn't simplify any further. All right? So let's try another one here. Okay, let's try another one. Let's see here. Are you guys ready to try one? You want to see another one? Okay. Let's do another one together then, and then I'll have you try one. All right, let's do 2, 2, and then let's do 6, 10. Okay, like that, 6, 10. Okay, I'm going to label these points again. All right, so if I label them, Caden, how could I label this 2 right here? As an X, okay? X1 or X2? X1. Okay, very good. And then if we label that one X1, then Dylan, what do I have to label this 2 as? Y. 1. Right, because if that's x1, that one's got to be y1 then. Very good. All right, and then this 6, what do you say, Carson, what do I label this one as?
Oh, X1.
X2. Very good. Good catch. All right, and then how about the 10? Let's go to Mark. What do you say, Mark?
X1.
So that one's x1. This one's y2. This one's x2, and this one's, that's right, it's y2. Very good, Erica. Thank you for the assist there. Okay, that's right. All right, slope formula. You'll need to have this memorized, folks. y2 minus y1 over x2 minus x1. Don't worry, we're going to do it so much, it's going to be drilled into your brain. You're going to be dancing at homecoming on Saturday night. You'll be thinking y2 minus y1 over x2 minus x1. Okay? And you'll be like, darn it, Mr. Wid. Okay, so let's plug in our numbers. We already labeled it, right? So 10 in for the y2 minus 2 in for the y1. 6 in for the x2 minus 2 in for the x1. Okay? Okay, Sean, can you simplify this for us? What's 10 minus 2, Sean?
8.
8. Sean, what's 6 minus 2? 4. Sean, can you tell me, does this fraction simplify at all? 8 over 4?
Yep.
It does. What does it simplify to be? Tell me what to do. How would I simplify this? Do you know how to simplify fractions? It's 2, or 2 over 1.
Yep.
That's right. We can divide the top and the bottom by 4. Okay, or 2, but then you can divide by another 2. So there's our answer. Good job. Okay? Ready to try one on your own? Yeah. Yes. Okay, that's what I like to hear. Okay. Here we go. You guys try this one. Okay, see what you can come up with here. Let's have you do -3, 7, and 1, -9. Okay, let's go ahead and try that one. You don't need to label the points if you don't want to. However, if you find yourself making mistakes, first thing I'm going to ask you is, are you labeling your points? Okay. So, give it a try. Write it out. Calculate the slope. You can use your calculators if you want to. But please do show your setup at least. Please show your setup at least for the slope before you plug in your calculator. Check minutes. So be careful of your order here. You did this one minus this one. Oh wait, no. 1 minus, it should be -3. You have 1 minus 3. It should be 1 minus 3. Minus and -3 is not the same thing as -3. Minus -3 is the same thing as adding positive 3. Yeah, that's actually the calculator. See, just check it out for yourself. 1 minus 3, 1 minus -3. Watch. Okay. Good. So remember, what goes on top? What do we subtract on top? So you just flip. Good. Very close. -16 divided by a +4 should equal. Well, no, try type what you just wrote in there again, and then hit enter and see. It should give you.
Oh, you're right, -4.
So it's, remember, we subtract the slope, so it's minus. So 1 minus -3. You do the same thing, change the mean, then it'd be plus +3. When you change it, you change both the sign.
But still, I still got it right though, right?
It should be a 4 on the denominator. Yeah, come on. 1 plus 3 is 4. Okay? All right. So, Let's go to Matt T. Okay, so Matt, what's our setup here for the slope?
Negative 9 minus 7.
-9 minus 7 over
1 minus negative 3.
1 minus -3. Okay, so x1, y1, x2, y2, right? And there they are. Folks, does it matter whether I subtract the y's or the x's on top? It does. It does, okay? For the slope formula, it's the change in the y's on top, the change in the x's on the bottom, okay? You may remember that another way you talk about slope is using the words rise over the run, okay? So some people have heard it before, right? The rise deals with the y's, so the y's are on top, right? The run deals with the x's. It doesn't rhyme, unfortunately, but that's on the bottom, okay? So dependent over independent, rise over run, y over x, always. Now, do I have to label this point as x1, y1? Could I label this point as x1, y1? You can. And then that would be x2, y2. So let me show you what I mean by that. Matt labeled this one as x2, y2, this one is x1, y1. We do the math here, we get negative 16 over 4, which simplifies to negative 4. But if we switch the order, okay, if I switch the order here, and if I did 7 minus negative 9, and then I did the same switch of the order with x's, so I did negative 3 minus 1, 7 minus negative 9 gives me a positive 16, negative 3 minus 1 gives me a negative 4, aren't these the same? Negative 16 over 4 and 16 over negative 4, aren't those the same? They both give us negative 4, okay? So they're both right, or negative 4 over 1 if you like, okay? So that's the idea there. Okay. Questions on any of that? All right, do we need to do another one, or are you guys feeling okay?
Switch it. I don't understand why you can switch it like that.
Switch the order because the slope from one point to another should be the same as the slope from the other point to the one. It should be the same slope regardless of which direction you're going. Notice the negative sign does end up a different spot, but then overall it's still negative. Okay. Yeah. Okay. So, I want to talk about one more thing here. Some other kind of strange things you can run across.
Would that be a trick question on the part, reversing it like that?
No, but I just wanted to, you can, depending on, like, you can kind of, like, manipulate things sometimes about, like, when you want to, you know, sometimes people like to subtract a positive instead of subtract a negative, so they can manipulate things around to help out with the mathematics. Okay, let's try this one. Okay, so let's go to, someone I haven't talked to yet. Daniel, can you set up the slope here for me? Okay, what would it be? What minus what over what minus what?
5 minus 3 over 4 minus 4.
Close.
It switches around.
Yeah, so 4 minus 4, the y, again, y1, y2, x1, x2. So yeah, subtract the y's and subtract the x's, so 5 minus 3. Okay, now, what's 4 minus 4? 0. What's 5 minus 3? 2. Okay, do you need sticky notes?
Sticky, there we go.
Sorry, I had them. 0 divided by 2. What's that equal? 0. Okay, we can have a slope of 0. Okay, we can have a slope of 0. That means that we're not going up or down, but we are going maybe left or right or something like that. Okay, so you can have a slope of 0. Okay, so keep that in mind. Or you can say this too if you like. All right, one other kind of weird slope we can run across too. Do this one more here. Okay, one more kind of weird slope here. This is, so 0 slope obviously is what that's called. Kendall, how do we set up the slope for these 2 points? How can we find the slope or the average rate of change between these 2 points? What would we write? 10 minus 3 over negative 5 minus negative 5. Okay, again, that's x1, y1, x2, y2. Okay, so 10 minus 3, Kendall, what's that? 7. Negative 5 minus negative 5. It's a bit trickier, isn't it? So again, I'll change it. Instead of minus and negative, I'll make it plus positive 5. It says the same thing. What's negative 5 plus positive 5? 0. What does this equal? let's type in our calculator and see what the calculator says. Okay? If we did 0 divided by 2, that did give us 0. Right? 0 divided by 2 gives us 0. Let's try 7 divided by 0. Whoa, we can't divide by 0. That's right. Okay, Catherine? Yes, very good, Catherine. You remember that from another class? Good job. Yes, undefined is what this is called. It's a very special slope as well. It's got a special name there, okay? Undefined is what we call that. And the reason why we call it undefined is because there is not a single value here. This is actually approaching, it's infinity is what it is. Okay, 7 divided by 0 is infinite in this case. Okay, so we call it undefined. Okay, defined means it's definite. It's got a value. Infinity kind of goes on forever. Okay, so we get a little error there. All right. I've got a few more questions I want to go over with you, but they are going to require us to have a visual. So, you mind passing one out, please? Thank you. Okay, so focus in on number 1 here. Focus in on number 1. But of course, mon ami.
Wait, what?
Yes, oui. Da, ya. Si.
Yes?
Yuppers, that's a yuppers.
Is it wallpaper?
No.
What is it?
Is it without paper?
It's, hold on a moment, all right? Hold your horses. Shh. Okay, I know what you're trying to do, but just hold on. Shh. Okay, so the directions here ask us to find the slope of each line, but we have not yet found slope when we're given the graph of a line, okay? But we can still do it, okay? Tyler L., can you refresh our memory? What is the slope formula?
Y2 minus Y1 divided by X2 minus X1.
Very good. See, Tyler's already got it memorized. You guys can memorize it too. Okay? Tyler's already got it. Or maybe he wrote it down and just read off his paper. That's what the paper's for. That's not cheating. That's what you're for. That's what it's for. Now, up to this point, in order to write the equation, in order to write the slope of something, in order to find the slope, what information do we need? All the problems we did prior to this, in order to write the slope, what information do we need? We needed 2 things. What 2 things do we need? We need 2 points. We need 2 points, okay? So let's look here at our line. Do we see 2 points on our first line here, number 1?
We do.
Yes, we do. Who said yes, we do? Alex? Alex, give me the coordinates of this point, please.
Looks like -1, -1.
Well done, Alex. Alex, can you give me this coordinates as well?
Looks like 2, -2.
Oh, my goodness. So all we had to do here, pull those points, okay, out, pull them out, right? Write the coordinates down. And now that we have the points, we can just label them like we did before. X1, Y1, X2, Y2. Okay? So, Mark, fill in the slope formula for me here. Slope is going to be what? What minus what over what minus what here?
-1 minus 2.
Be careful. Remember, the slope is, we subtract the y's on top. So it's y2 minus y1. So what's that going to be in this case?
Oh, Y2 is
Negative 2 minus negative 1 over
2 minus -1.
Very good. Okay, very good. That's right. And so we'll just do this math. Instead of, again, you can put in your calculator if you want to. Instead of subtract the negative, I'm going to add the opposite. Doggone it. So -2 plus 1 is -1. Oh, that's right. Miss Mulcahy to the rescue. All right. So -1 over 3 is our slope.
That was a lot of work.
Was it?
Yes.
Catherine says, nah.
Nah, it's easy.
Carson?
Nah.
Oh, you were waiting?
Yeah.
Okay.
All right, let's try another one here.
Oh, wait,
Number
you missed that.
3.
Go back to that. Go back to that. Did I do it right?
Negative 1/3, Miss Mulcahy. All right, very good. All right, let's go to. Oh, Mark already got you. I'm not going to make you do it again. Let's go to. Oh, Kendall already got you too. Let's go to Reagan. Reagan, number 3.
Okay, we're gonna find the slope here, Reagan. Okay.
Yeah.
What do we need to find the slope of a line? How much? What information do we need?
The point.
Okay, how many points?
There's only 2.
Well, there's
Or
only
there's
2
3.
here.
No.
Only 2 shown, but we need 2 though, right?
Yeah.
Okay, so 2 points. Can you give me the coordinates for this point right here?
Yeah, that's -5.
Yeah, it's kind of hard to count. I think it's 1, 2, 3. Oh, it's -4.
-4.
-4, comma, what's the y coordinate? Give her a chance. And so it's on the x-axis, right? So it's not above or below it. So it's 0.
Yeah, so it's 0.
Yeah, it's 0. Okay. And then, that's okay. And can you do this one for me too, please?
Sure.
All right. So
Is
what's the x coordinate?
-3.
Oh, -3 for the y. Okay, we did go down 3. Yes. And what's the x coordinate? How far over did we go from the origin there?
2.
Yeah, so -2 because we're going to the left there. Okay, that's right. That's right. Okay. All right, so let's go to Dylan. Dylan, how am I going to label this number? -4 is x 1, and then y1 there. Okay, and then -2 would be x2, -3. -3 is x2 as well?
No, y2.
Y2. There we go. Woo! I know you guys are already thinking about that sweet, sweet pep rally. You're so excited. I know. All right, Matt S. Oh, speaking of sweet, sweet pep rallies, but not really. All right, Shepherd at 12:50, so a few more minutes here. Peace out. Okay. All right, anyway. Slope formula here. Let's do this. So let's go to Matt. Matt, remember, slope formula is y2 minus y1 over x2 minus x1, right? So set it up for us here.
Wait, can you push it up a little?
Yeah. How about I'll zoom out some maybe so you can see it? There. There's the slope formula right there. So what am I going to write here? What numbers?
-2 minus.
So careful. We'll start with a y2. What's the y2?
Oh, -3.
-3 minus
0.
0 over.
-2 minus -4.
Perfect. Good job, Matt. -3 minus 0 is -3. -2 minus -4. Again, I don't like subtracting negatives, so I'm going to make it plus positive. It's the same thing. It leaves me with 2. Okay? So there it is. Hello.
Just want to make sure we're on the
Start
same
warming
page.
up. I should start stretching.
Same page today, yes. Are you?
Are we ready for the juniors today?
Are you guys?
Okay.
You guys are a team in the relay race?
That's right.
So excited.
Yeah, sorry, I'm so sorry to interrupt. I just want to make sure we're on the same page.
As long as it's an important interruption, and what's more important than this?
Right.
So there we go.
Remember, right, left.
Right, right, left, right, left. We'll practice a little bit before we have to go. Yeah.
Correct.
Okay.
Thank you.
Yep. No, you're welcome. Thank you.
Oh, no, wrong.
No. Twist an ankle. Why? You're trying to leave me, Alex. It's on the board. Thank you, Reagan. Thank you. Okay. So I'm going to save you some time here, though. Okay? I'm going to save you some time. If you look at these points that we've been using, okay? These points that we've been using, right? We put them in the slope formula. But you don't have to use the slope formula when you have the graph. Let me show you what I mean. If I go from this point to this point, how do I have to move? Give me the y change first. To get from here to here, what's the change in the y that I have to do? I have to go up or down? Down how much? 1. And then how far over do I have to go? 1, 2, 3. So I'm going down 1. So down would be like a -1, right? And I'm going right 3 and going in the right direction, like a positive direction. Oh my gosh. Down 1, right 3. Look at that. Let's check it with this one. okay, from here to here, okay? If I'm going to get from this point to this point, again, up or down, which way do I have to go? Down, 1, 2, 3, and then right or left? Right, 1, 2. Down, 3, right, 2. Oh my gosh, we don't even have to use a slope formula if we don't want to when you have the graph, okay, and you pick out 2 points. All right, so your homework then is to finish up through 15, the odds, please. Finish up through 15, the odds. So numbers 1 through 15, odds. Okay, and that'll be your assignment. All right, so you can probably get 4 and 5, or 5 and 7 done like that because of what I just showed you. But you can also use the slope formula if you want to, too. Okay, your choice. But that is your assignment. Okay, circle them if you need to. So 5, 7, 9, 11, 13, 15. Okay? And that will be your homework if you don't finish in class.